In this video we're going to look at questions which combine observations from Group 2, Group 7 Chemistry and moles calculations. This is something that could possibly come up on your paper 1. So here's the first question. A sample of solid magnesium halide was dissolved in water to form a solution. The solution was acidified with nitric acid and was treated with excess silver nitrate until no more cream precipitate was formed. The precipitate was filtered and dried in an oven at 40 degrees Celsius to leave a solid with a mass of 1.041 grams. Identify the magnesium halide used. Calculate the mass of the solid magnesium halide used, initially in milligrams. So where do you start with a question like this? You start with your knowledge of Group 7 Chemistry. The halide solution was acidified with nitric acid and was treated with excess silver nitrate. So the nitric acid is there just to dissolve any residual carbonates, make sure there's no negative ions interfering with this test. And then it's the reaction between the silver ions and the halide. And it's the colour of this precipitate which tells you which halide it is. So hopefully you have worked out that the solid is silver bromide because it's a cream colour precipitate. And it's got the solid state symbol because it's a precipitate. So the first step is calculate the mass. So 1.041 grams is the mass of silver bromide, not the magnesium bromide, but the silver bromide. So you need to calculate the number of moles of silver bromide, dividing through by the MR of silver bromide, which gives you a value of 5.543 times 10 to the minus 3 moles. Now you need to know how much magnesium bromide generated this. So the stoichiometric equation, which you could be asked to derive yourself. So you got 1 magnesium bromide plus 2 lots of silver nitrate gives 2 lots of silver bromide and magnesium nitrate. So the stoichiometry of magnesium bromide to silver bromide is that you've got twice as many moles of silver bromide than magnesium bromide. So therefore your moles of magnesium bromide is 5.543 times 10 to the minus 3 divided by 2, or multiplied by a half, which gives you a number of 2.772 times 10 to the minus 3 moles. So you've got your number of moles of magnesium bromide. Okay. Now we need to convert that into a mass. So if we multiply the mass by the MR of magnesium bromide, which is 184, that will give us the mass in grams. So that gives you a value of 0.510 grams. But the question asks for the mass to be given in milligrams. So we need to multiply by 1000 to give our final answer of 510 milligrams. So quoting to 3 significant figures. Next question. 150 cubic centimeter solution of a group 2 chloride was treated with excess dilute sulfuric acid, forming a white solid. The solid was filtered and dried in an oven at 40 degrees Celsius until no further change in mass occurred, giving a mass of 692 milligrams. Identify the group 2 chloride used. Calculate the concentration of the initial group 2 chloride used in the units moles per decimeter cubed. Okay. So, again, the starting point is your observation from the group 2 chemistry which has occurred, i.e. the metal ions reacted with dilute sulfuric acid and formed a white solid. This should scream out to you barium sulfate. That is the white solid. Okay. So the 692 milligrams is the mass of barium sulfate formed. So what we need to do is convert that mass into grams, and then once it's in grams, then we can convert to moles. So divide by 1000, and then divide through by the MR of barium sulfate, which is 233.4. So this equals 2.965 times 10 to the minus 3 moles. Now we need to know how many moles of barium chloride we started with. So stoichiometric equation, barium chloride plus sulfuric acid gives barium sulfate and 2HCl. So we've got a one-to-one stoichiometry, so we can quite simply say that the moles of barium chloride equal the moles of barium sulfate. So we've got our moles of barium chloride. That is the number of moles of barium chloride in 150 cubic centimeters of solution. So we can calculate our concentration. Now, when we're calculating our concentration, we need to divide through by our volume, our number of moles by volume. And it's quite simply this equation. If your volume is in decimeters cubed, if it's not, then you need to multiply your number of moles by 1000 and then divide by your volume in centimeters cubed. Or you could take your number of moles and divide by the volume divided by 1000. It depends how you want to do it on your calculator. I'm going for me the easiest option, i.e. I'm going to separate my calculation out. So 150 cubic centimeters is equal to 0.15 decimeters cubed. And so I'm going to take my number of moles and divide by my volume in decimeters cubed. And that gives me an answer of 0.01977 moles per decimeter cubed. But again, that's 4 significant figures, too many significant figures really. So round it to 3 sig fig. So my final answer is 0.0198 moles per decimeter cubed. Hopefully you found this little video helpful. Thank you for watching.